In this video, we're going to learn how to solve quadratics by completing the square. So we've seen factoring and then square root principle. This is going to use the square root principle like we learned in the last section, and actually a little factoring that we learned earlier as well. But we're going to manipulate equations that aren't perfect trinomial squares into being perfect trinomial squares so that we can use the square root principle. If you remember in the last section, we would end up with things like x minus 7 equals 10, and then we could square root both sides of that to solve for x. So that's kind of completing the square, is getting it into this form so that we can use that method. So there's some steps here. I'll go through those in a second. These first couple of questions are just really working on this magical middle step right here. And it's what do we need to add right here so that this factors to one of these, in this case it's a plus, so that it'll factor to a perfect trinomial square. So if you remember on our trinomials, they took the form a squared, I'll do the positive one just since this one's positive, 2ab plus b squared. And so what we're trying to do is we're trying to find b squared. What do I put here so that that's going to factor to a plus b quantity squared? Because if it does, then I can root both sides and solve. To get at b squared, we need to get rid of a 2, because this is going to be 2ab. The a we actually don't have to worry about because the x squared is the a squared. So essentially 2ab, oops, and I put the a there anyhow, 2b equals 16. So I need to get rid of the 2 in order to isolate b. So I'm going to take half of both sides. You can also divide by 2. I'm going to think of it as taking a half. And then that gets me b equals 8. And then we'll square both sides of that. And b squared is 64. So that is the number that I have to add onto this equation for it to factor in as a perfect trinomial square. So the short version with a little less talking on how to do that is you take half of the middle term, so half of 16 would be 8, you square it, that makes 64, and that is what you would add on to that to make it a perfect trinomial square. When this is factored, it would become x plus 8 quantity squared, because remember b was 8, that was the number we squared. And this works for any trinomials. Because of this taking half step, if this middle term is odd, like say it was 7, I would then have half of 7 would be 7 halves, and squared would be 49 fourths, and now I got a bunch of fractions running around. So I don't prefer this method for any questions where this is an odd number. We'll save those for the next section. All the ones that I picked in here are all ones that would be solved easier by completing the square than quadratic formula. We'll see in the next one. This one is the same thing. We haven't solved this yet. These first couple of questions are just kind of getting you to figure out how to take half of b and then square it. And then in a second we're going to add that to both sides. But for right now we're just working out that one little step of half of b and squaring it. So for this one, half of 10 would equal 5, and then 5 squared would equal 25. So 25 is what I have to add right there to make this a perfect trinomial square. When I factor that, if we're factoring, remember what multiplies to be 25 adds to be negative 10 would be x minus 5 quantity squared, and we made it one of those perfect trinomial squares. So we'll come out to those, but it also fits with our multiplies to the n. That's the middle version of factoring. So for completing the square proper, we got these steps up here. So let me go through those now. First thing we're going to want to do is move the c term, get it in as ax squared plus bx, and then equals negative c, which is just to say we want the constant term over on the right-hand side instead of set equal to 0. If a does not equal 1, we're going to divide through by a. Mostly we want to do these when a does equal 1, because when you divide through by a, that can introduce fractions. So again, that would be one that would be easier to use the quadratic formula in the next section. Then we're going to take half of b, square it, and add the result to both sides of the equation. After that, we're going to factor like we did right here, and then we'll use the square root property like we did in the last section to finish solving. So it sounds like a bit, but it actually is not that terrible once you kind of get the flow of it. At least for problems where a is 1 and b is even. So this one is in the right form, so I'm just going to write that down here. And I'm going to leave myself a little room. And so this is where we're going to, a is 1, it's already the one, this is already on this side, so we're good. We don't have to divide through by anything because this is a 1 as well. So we can go half of 14 is 7, and then squared is going to be 49. So we'll add 49 to both sides of this equation. So that's the adding to both sides step. And then the next step was to factor this. So y plus 7 quantity squared equals 1 plus 49 is 50. There we go. And now we're right back to what we were doing in the last section. We'll take the square root of both sides. Don't forget the all-important plus minus there. And remember, that's because when we're taking this school, when we have x squared equals something like, say, 9, x could be 3 or x could be negative 3. They both make 9. So remember, we need that plus minus. So then y plus 7 equals plus or minus root 50. And then move the 7 over. Negative 7 equals, negative 7 plus or minus root 50. When you look at the answers on these, they're going to have the 7 after the 50. That looks super weird to me. Every book I've ever seen writes it in this order. I double checked, the computer does take it in this order, so I would just do it in this order. The other weird thing about the problems in this section in particular, in the next section I think they make you simplify, and in the last one they did as well, but whoever programmed these completing the square questions did not require that you simplify this 50, and that is actually not proper. So this is going to be the computer answer, and then I'm going to pop over here, and then this is the right answer. If we have something under a root that simplifies, we should always simplify it, like we saw in the last section. So 25 times 2, and then remember we could think of those as two separate roots, and then y equals negative 7 plus or minus 5 root 2. So this right here is really the proper answer, and I did plug that into the computer as well, and it took it, but the computer will mark this right, even though it's technically a step or two from actually being done. And that's it. So now we're just going to do a couple more examples and kind of get into the flow of it. So we got y squared. I'm going to bring the 10y over so that I'm in that the terms with the y are on one side, the constants on the other. We'll go half of 10 is 5, and then 5 squared will be 25. So y squared minus 10y and then plus 25 equals 12 plus 25. So we'll factor this. Y minus 5 quantity squared equals 37, and then we root both sides. Plus or minus. So y minus 5 equals plus or minus square root 37, adding the 5 over, y equals 5 plus or minus square root 37. And then 37 is prime. There's nothing to simplify there, so that's as far as that one would go. This one's pretty much the same thing, so we'll write it as x squared. The 8x should be on this side, and the 2 should be on that side. I'll leave myself some space there, and then adding the 2 over. And then we'll go half of 8 is 4, and squared would make 16. You might have noticed that I never worry about that it's negative at that step. I know I'm adding it to both sides because both those trinomial square formulas are plus b squared. And when I do half of negative 8, it would be negative 4, but when I square it, it's still going to be plus 16. So you'll hear me kind of skip over that because it's always going to be positive. This would factor to x minus 4. Quantity squared is always whatever we squared, equals 18. And then we'll root both sides on that. And x minus 4 equals plus or minus root 18. And then bringing the 4 over, we'd have x equals positive 4 plus or minus root 18. And that's another example where that's the computer will take that answer, but it really should be 4 plus or minus, this is a 9 times 2, so that should be 3 root 2. So that would be the proper answer. And then this last one, so this is one where a is not 1. So let me rewrite that down here. And there's two ways that we could do this. Up in the answer box up there, it says to divide through by a, which is totally fine. In the notes, and actually that's good if this was going to leave fractions, that would be a problem. This one doesn't, it divides in evenly, so for me, you can also just factor this out either way. In the notes, I factored it out, so how about in this one, I'll divide through by 5 and just show both versions. So then 5 over 5, that would just leave us x squared, and that's what we're trying to get to, is to a 1x squared. 30 over 5, that would give us a 6x, and then plus 30 over 5, that would give us a plus 6, equals 0. And you can see why, if this isn't a 1, this is maybe going to not be the best method. The ones in this section, like I said, I picked problems that behaved well. But let's say instead of a 5, let's say this had been a 7. And then you'd have 37ths plus 37ths, and half of 37ths would start getting kind of dicey. And then you have to square that, add it to both sides. And so again, that's kind of where I would use quadratic formula. But as long as you end up with something where this is 1 and this is even, this is actually easier than the quadratic. So we'll do x squared minus 6x, and let's leave some space. Bring the 6 over. And from here we're going to do half of 6 is 3, and 3 squared makes 9. So plus 9 and plus 9. Factoring, we have x minus 3 quantity squared, and on this side, negative 6 plus 9 would give us a 3 over there. And we'll take the square root of both sides, plus or minus. X minus 3 equals plus or minus root 3, and adding the 3 over, x equals 3 plus or minus root 3. I don't think I've written that as a list yet. In the event, sometimes the answer box, they have different programming depending on who wrote the questions. But if it wants it as a list, where it just has a big box, like if it was factoring, you would write x equals, oops, that didn't work out, 2 comma 5. So if it was that kind of entry, this would be 3 plus root 3, comma 3 minus root 3, just to make that sure that's clear from that plus or minus. Cool.